to the country and you want to grow your own food. Well, the first and most important thing in growing food is light. You've got to have enough light. This is a wooded area up here, but where we want to put the garden and we are putting the garden has been cleared in the past, and there's plenty of light. So that's an important thing. I know many people have attempted to grow in their yards and with insufficient light. I was invited up to someone's new home that they had bought, and they were trying to squeeze things in to not plant in their big spacious front lawn where all the light was. And I had to let them know there's not sufficient light to be able to grow certain things that you're trying to grow. There's a few things that will grow at the edge of the woods. Your black raspberries grow well at the edge of the woods. Japanese jewelberries will do that too. Your gooseberries and currants can grow at the edge of the woods, but most places you need light, and you need plenty of light. For growing plants, for their leaves, say your lettuce, your kale, your collards, you need a minimum of 6 to 8 hours of light a day. Okay, so that limits you. Now, another thing that's important to understand is, where are you? Are you in the tropics where the light is so intense that it stops growing, stops plants from producing sugar, which is the basic nutrient that feeds us? It develops further into starches and develops into oils and is necessary for the development of proteins, but that stops being produced in excessive sunlight and heat. So it depends on where you are on the planet. But basically, when you're talking the United States, a temperate zone area, you need 6 to 8 hours for leaves, 8 to 10 hours a day for roots, potatoes, carrots, beets, and 10 to 12 hours a day for fruits, squashes, tomatoes, peppers, cucumbers. So light is the first thing. Once you have that, then you can begin at that point. The next most important thing is water. Do you have a good water source? There's been a lot of rain this spring, and I don't think I've had to irrigate, and I began planting in the end of March, beginning of April. I think I put the peas in. They're the first thing that'll go in. And you put things in an order. People ask me, when do you plant? And it's like, when you're supposed to. We eat a lot of different variable foods. And I grow from, probably about 35, 40 different things. And that includes, my herbs that I'm going to have, because, I want dill when I make my dill pickles. And, I want basil when making tomato sauce up, putting it up and canning it for the year. And so all these things have different times. And I begin with the peas first. They can even you can even drill a hole in frozen solid soil and put a pea seed in, and when the soil defrosts, it'll grow at the right time when the soil temperature warms up. And all the way, and that starts, here around where I am in late March. As soon as the ground is defrosted, I put the peas in. And I put some of the last things, and they're not even the last, because you actually have a fall crop that you can put in. The same thing you grow in the spring, you can grow again in the fall. But one of the last things I put in is my sweet potatoes, because being in Connecticut, where I come from, Connecticut is quite cool, and sweet potatoes don't like to grow there, so they're not going to do anything when you put them in the ground until it starts getting hot, and it doesn't get hot enough for them to start growing until by about mid-June, maybe the first week in June, but by mid-June it starts getting pretty hot and things will begin to grow. So that's when you plant. So that's your planting time. And it can vary all the way up. Every single different thing you're growing has its own planting time. So you have to learn that. And I have made a planting time chart. I don't have a copy right here, but that can be put online, the planting chart time. So we have light, and that's the most important thing. The second thing is water, because plants need water. Without water, don't even waste your time putting on fertilizers. Um, don't even waste your time trying to create. Well, I wouldn't say don't waste your time trying to create a fertile soil, because increasing the organic matter content, which holds water, makes the rains that you do get last longer. Also, putting on a mulch around the plants you're growing keeps the water from evaporating so that you can go longer between rains. And as the mulch breaks down into humus, that too is that water holding organic matter that allows you to go longer between rains. Now, it dries out, and this is where you're going to need either gravity flow water. You're going to have some type of system where you've collected water. It could be a pond uphill. And if you have an area where water naturally flows downhill, you can put your garden below that point and have a pond above that point and use that pond during those times when it gets extra dry. Now that's going to take equipment. It's going to take bulldozer or any type of equipment to dig out that pond, but at least you'll have gravity flow. You could have a cistern of some type and have a solar system that, it sounds like the same word. A cistern is a pipe which you put in the ground where there's naturally water, and the water table is up so that it keeps that cistern with water in it. And then you can get a solar electrical power source to pump the water out and let it gravity flow into your, well, it wouldn't be gravity flow. You get it up to a point where it can then flow into your garden and water your garden that way. So, or you can have electricity, and in which case then you can have electrical pumps that can build pressure, and then you can sprinkle you have sprinklers and irrigate that way. But water is necessary. You're not going to get much growth. The plant may hang on and not die in an environment up here like Connecticut, which is naturally on the wet side. Your East Coast is naturally on the wet side, but you can have periods where it's so dry you can even lose your crops. So those are the two beginning points: light and water. Without them, don't even try. Don't even try to grow food. This is the way God designed things, and we have to be able to operate the way He designed it. Now, the next two most important things are the soil itself and the very plants and their seeds themselves. Now, the soil God has designed, and we mentioned it earlier today in Genesis 2:5, we were given the responsibility to care for the soil. It says in Genesis 2:5 that there was not a man to till the ground. So that ground, God gave us a responsibility for it. Now that word was put in by the King James writers as till, but in Hebrew, it's a work of service. The King James writers thought, well, what work of service do we do to the ground? Oh, obviously, we till it. That's not the Hebrew. The Hebrew is a work of service. So there's some service that we have to do to the ground. And this is the soil that our plants grow in. There's also that same word, work of service, the Hebrew word for a work of service. It's abad. Abad, actually, is how you pronounce it. In Genesis 2:15, it says we were to dress the garden and keep it that way, and keep it in 2:15. And that word dress, again, the Hebrew writers thought, well, what is that work of service we do to the garden? Well, we put on a side dressing. Side dressing is like a fertilization. It could be even just a mulching system that fertilizes as it decomposes. It could be putting something else on that's going to improve the conditions. You know, many people put a chemical side dressing on, many growers do, or even people who make compost put on a side dressing. This world record tomatoes here, he tells you how to make a compost here that he puts on that after you have a very heavy rain and it washes the electrical current out of the soil, he teaches you how to put on a compost and how to make that compost that will recharge the soil again and get it growing so you don't lose time from the excessive rain. Soil is a work of service that we have to do, and the other work of service for the garden is actually part of the design, but we'll talk more about the design later. So the soil is the home for microbes. Now, the word microbe means microscopic, and that means you can't see it with the naked eye. Matter of fact, what has been learned about the soil could not be seen even with microscopes for 100 years or more. It was only when recently electron microscopes were made where you can see all the way down to the DNA level of microscopic creatures that we learn what is going on in the plants. And as a matter of fact, how plants are fed has not been learned except in the last few years. And what has been learned in the last few years is that plants do not grow with fertilization. We've always been taught that. All my life I've been taught that. I'm 73. I've been taught all my life and have thought all my life that the fertility in the soil was the nutrient content in the soil. Well, there is a nutrition. There is nutrients in the soil, but they are in the form of live creatures. Plants swallow live, living creatures. That's how God designed them to grow. The process is called rhizophagy. Rhizo, R-H-I-Z-O, means rhizome, it means root, and phagy means phagocytosis. It's the engulfing. And the roots of a plant engulf microbes. They take them in live. Now, you can also force nutrition into a plant. That's called hydroponic growing, and that's the way most commercial growing is conducted these days. They just use the soil to hold the plant upright. But what they do is they pour on these water-soluble nutrients, and then they just wash themselves into the plant. The plant has a design whereby they receive the nutrients from these living creatures that they swallow. And as they make that exchange, these living creatures give up their nutrition to the plant. It's in a water-soluble form as they make that exchange. And that exchange they can just flood it right in. Okay, thank you for those papers there. This is the planting guide. I guess Renoir's going to some way put it out there so you can get it. I don't know much about computers, so I don't know how it's done, but he can get you this planting guide, and this shows you from beginning of the season to the very last ones that go in, what time to plant them all. Now, this rhizophagy plant engulfment of living creatures, and these living creatures are bacteria, they're fungi, they're algae, they're yeasts, they're viruses. These are all beneficial now. Every single thing that feeds the plant is beneficial. We may have the concept that if it's microscopic, bacteria is bad. If it's microscopic fungus, it's bad. Viruses are bad. On and on. We can think things are bad, but God designed everything, as it says in Genesis 1:31, very good. All the microbes we have today that are pathogenic, patho means bad, let's just call them bad. They're the bad ones that make you sick. All of them that we have today, we have made them. God told us how to care for the soil. He told us how to plant the plants in garden designs. And when we don't do it, things change. Microbes change from good guys to bad guys. And just as people can be good guys and become bad guys can become good guys again. And so this is what we're having to learn to do, is how to change the environment. This is why I have a paper on epigenetics. Change the environment, because when you change the environment, you change the genes. You change the genes of these food supplying microbes to beneficial ones. Or we can change their genes and make them sickening microbes. An example of creating sickening microbes is that God designed these fungus that are swallowed by the plant to feed. There's two types of fungus. Some are open up and allow the plant to swallow them, take them. Others just bring their nutrients right to the edge of the plant and then make their exchange there. Those are the ones where our water-soluble fertilizers can flood their way into the plant at that point. You know, they come to the kitchen door and bring the food. Others go into the kitchen and put it on the counter in there where it can be prepared and used. And so you have these types of fungus, but they have to feed first out in the soil and gather up nutrition for the plant. And when these fungus have had the microbes in the soil that they need to feed from first before they go and attempt to feed the plant, if they've been killed off, because in many cases we take the seeds that are carrying these microbes so that when they start to grow, they'll have their little buddies there with them to feed them. When we kill them on the seed with seed treatments, have you ever bought grass seed and it's white or blue or green? Those are neonicotinoids put on there, insecticides, and they kill off the good microbes on the plant. Or you put fungicides on seeds. Have you ever seen them? Bought seeds and they had coloration on the pink colors on them, of fungicides on them, or steam treatment. They take an almond seed and they steam treat it, and supposedly to kill the bad microbes on the almond. That kills the good ones too. And so when you plant a seed and it's had these microbes that are its buddies there to feed it, killed off, that fungus, when it feeds out in the soil and then attempts to feed the plant, actually sickens the plant with the diet it provides. You know how it is. You can provide a good diet or a bad diet. Oh, I have to take a moment here. We went for a walk, and here's a tick coming up my sleeve. He climbed up my clothes, so I have to kill him. Yeah, that's one of the things about being in the country, just having to take care of ticks when you feel them walking on you. So you have these microbes in the soil, and they need to be treated. The soil environment needs to be treated properly, because if it doesn't, what these fungus are that feed the plant, they become pathogenic. And so we say they are genetically changed. They become pathogens. The environment changed them. And who's responsible for the environment? We're responsible for the environment. We're responsible for the environment of the ground, Genesis 2:5. That is our service, to serve the ground and take care of it so we get healthy plants. Everything was created good. That's the way God designed it, but we can mess it up, and we're really good at that, and we have an excellent example of how to mess up this planet going now. But God, in his mercy, because his people are not going to be able to buy or sell, are being shown his system. He let people invent the electron microscope so they can learn about this rhizophagy process, and then they can start learning to take care of the soil in such a way that we develop these microbe populations in the soil. So when we're talking about soil, these microbe populations, they need housing. They need apartments. And this is what the organic matter, which breaks down into humus, provides for them. It provides housing. They need apartments. And this organic matter, this humus, is a honeycombed structure. Just picture the honeycombing. It's just a lot of holes. And in those holes, in a good soil, half the holes have water and the other half have air, because they also need air. These microbes are, many of them, or most of them, are aerobic. They need air. And they need air not only to breathe, but they also, many of them need air because the air is over 70% nitrogen, and they take that nitrogen out of the air, and it's what's combined with the sugars the plant makes to make the proteins. So this is the operation that goes on. Now, in the tropics, humus, it comes and goes so rapidly, there's almost no humus in the topsoil. It is, by the time something hits the ground, within a couple of weeks, it's gone. It's consumed back up again, because microbial decay is so rapid in the tropics. So what do you do in the tropics for microbe homes? It is understood what to do, and had been done for centuries. And that soil was made good soil. And centuries later, when we went and burnt down the Amazon so we could plant commercial crops of corn and soybeans and sugarcane, they found those soils. They are called terra preta. Terra meaning soil and preta meaning dark or black. And this is the Portuguese name or Brazilian way of saying it. They were there after having been made by the natives hundreds of years ago. So this is what you do with soil in the tropics. You take the organic matter, you char it. They charred it. They built mounds of organic matter, the trees they cut down and all the stuff, and then they covered it over with dirt. And then they slow burned it. They made little holes around the edges, a hole in the top, some on the side. And then they monitored the slow burning process, so the carbon did not go back into the air, but the carbon was converted into microbe homes. In the northern climates, it occurs naturally, and the occurrence, the farther north you go, you say like Scotland and then Canada and things like that, there's so much humus built up that they actually have to create erosion purposely to erode that humus away so that they can get pine trees to begin to grow again in these very northern latitudes. So we have a very different climate. It shifts all the way as you go from the very northern places where people live and try to grow food, all the way down to the tropics where there would be no organic matter. It's all in the form of living organism. Like I said, it rots within a couple of weeks and is immediately absorbed back again into it. So this is soil. Soil is not only the mineral content, but most importantly, the housing for the microbes. Now, when you make compost and you say have a piece of soil, like up here, I could tell by the plants that are growing that the soil is not a rich soil. It's on the top of a mountain. And it has some slope to it, and it must have been farmed in the past and opened up and the forest removed and the topsoil washed away. The organic matter washed downhill because what is here is a small amount, and you can tell by what is growing out there. So that was damaged in the past, and because the forests initially, when the Europeans came over, were tremendously large trees because of the centuries and centuries of soil buildup. But like I said, most of the United States was burnt down, put into agriculture, soil worn out, and worn out by the turn of the 19th century. In 1906, a professor of agronomy from the University of Wisconsin made a comment after having visited the Orient, China, Korea, Japan, where they, and entitled his book, Farmers of 40 Centuries, they had taken such good care of the soil for 40 centuries that he wanted to learn how to do it, because he said every time it rained here in the east, the Potomac, Washington, D.C. is on the Potomac River, that's the capital of the United States, would run muddy because the agricultural land was just mistreated and the organic matter was washing off the soils and down the creeks. And this is over 125 years ago. So that's what we have is a poor type soil here, and we have to build that soil up, and composting is the way of doing it, taking organic matter, a percentage, say 50-50, green stuff, 50-50, dry matter, leaves is dry, weeds or grass clippings is green stuff. Mix the two together, and then try to put in there sea vegetables called seaweeds. And because they have all the minerals. Not only did the organic matter wash down because of our mistreatment of the soil, but the minerals washed out too. The oceans were not salty. The oceans were fresh water when God first made things. You could drink anywhere. This is adaptation, epigenetic adaptation of animals, that they can live in these salty environments. But that's the mineral content that was supposed to be in the soil and will be back in the soil again when God makes the earth new again. But our job now is to rebuild the soil. So if you want to be able to grow your food, you have to have rebuilt soil, and composting is one of the ways to do it. Another way to do it is to grow plants with your food plants that are building back the soil while you're growing your food. This is what regenerative agriculture is doing. There are three forms of agriculture today. There is conventional, that means unnatural, where we're using chemicals and things to grow our foods, and chemical sprays and stuff like that. And then there's organic agriculture, where we're using natural fertilizers and natural sprays. And then there's regenerative agriculture, where we grow plants on the soil that rebuild the soil and make the organic matter, and at the same time support microbes that convert the minerals and other materials in the soil into the food that the plants need. So in other words, in regenerative agriculture, you don't fertilize, you let the plants create the fertility for your crops by growing them with your crops. I'm growing right now oats on my sweet potato mounds. It's not time to put sweet potatoes in, it's not warm enough yet. And they're making fertilizer for the sweet potato. Then I'm going to put the sweet potatoes in the top of those mounds, and I'm going to put black tarps over the edges of them to smother the oats because I don't need them anymore. They'll just shade out the sweet potato. And they have been making fertilizer for 2 months. They've been making fertilizer for these sweet potatoes I'm going to plant there for the month of April and May and part of June. And so this is how we rebuild the soil while we're growing our crops. Some crops I grow in clover. I put them in like corn, and then I put clover down amongst it, and the clover takes off and germinates, but it doesn't grow too well. It doesn't get enough light, although this year I moved the rows farther apart, so they're going to get more light. So I'll have a better crop of clover. And then the clover makes nitrogen available for the corn. The clover makes potassium available, all types of trace elements available for the corn. And so this is a way of using plants to regenerate the soil and help feed your plants at the same time. So soil is the next thing, light, and then water, and then the soil itself. Now, with plants, we want to learn to save seeds from our plants. I found the best book, Seed to Seed by Suzanne Ashworth. And there are basically a dozen families of plants that comprise the seeds that we have to save. And once you learn how one family's seeds grow, everything else in that family grows seeds the same way, because they made the classification system of families based upon the flowering of the plants. And the flowers, of course, produce the fruit and the seed. Much fruit is just dry material, like the chaff on wheat or rice or oats. That chaff is the flower part. And the seed is the prominent part. Whereas the chaff on an apple is nothing more than that little calyx on the bottom of the apple, that little bit of dark material on the bottom of an apple. A seed of a peach, of course, is that pit inside, which sometimes those peaches are selected not for the fruit, but for the pit. And when we select these peaches for the pit, we call them almonds. And when we select them for the fruit, we call it a peach. So almonds grow pretty lousy peaches, and peaches grow pretty lousy almonds. So you can select for one thing or the other. Swiss chard and beets. Swiss chard is very tall green. It has a decent sized root, but it's not anything anybody eats. Yet a Swiss chard and a beet are the exact same plant, just one selected for the top and the other selected for the root. So that's why you can eat beet tops, but normally they don't. If you really want to eat something that tastes like beet tops, grow Swiss chard, and you can get some really big, tall ones, 3 feet tall or so. So we have the seeds. Seeds are what is going to begin our plant. Now, the seeds themselves are given by the mother plant a microbiome, just like a mother imparts to her baby. The microbiomes that it had, notice I used the word plural, microbiomes with an S, because not only does she give what we've been hearing about the gut microbiome to the baby, but the other microbiomes that it carries. We'll just focus at one moment at the gut microbiome that the mother gives, a mother human gives to the baby, because that's what the mother plant gives to the beginning baby. You know how in the Bible says the seed, talks about the seed of a man, the seed of people. And usually that is making reference to the sperm, but that's basically the role of the seed of a plant is it's actually a fertilized egg. You get the pollen in cross-pollination of the male, and it could be just the male. The flower could have a male part and a female part. Or like spinach, you could have a male plant and a female plant. That's why you have to leave enough of a patch of spinach. You don't just try to save seed from spinach from one plant. It won't work. It'll be male or female and you'll have nothing. So you need to know and understand, how the plant reproduces itself, and you'll learn that in this book here. It'll tell you how to recognize what family it's in by the way it grows its flower parts and produces the seed. And so now the seed, like I said, carries with it its microbiome. It carries with it the bacterias, the viruses, the fungus, the yeast, and whatever else is microscopically on that. And these are the buddies that help that little seed to take right off when it starts to grow. Because immediately when the seed germinates and the little greenery comes out, I call it greenery and I don't call it leaves because they're actually not true leaves. They call them cotyledons. It could be a mono, just one, like grasses, or it can be a di, it could be two, like the dicots, the two little leaves that come out from the seed. And these begin to collect chlorophyll. Okay, now the energy that came for those little dicotyledons to form came from energy stored away in the seed. And that's enough to get chlorophyll developing sugars. And now, when these little dicotyledons come out and they turn green and they start gathering that sunlight and they start making sugars, then they begin to start feeding these little critters. Down in the soil and out on the leaf surface, they start feeding them. And they start, in turn, feeding the plants. So the whole process all has to start all at once. And God has it all designed so that everything works together. And if we don't interfere, if we don't put fungicides on the seed, insecticides on the seed, use steam treatment, use acid treatment, use alkali treatment, we have a lot of ways that we can damage things. We think we're wise and we think everything evolved and we can be part of the evolution process. And I mean, that's the folly of evolution. It coaxes us on to think that we can create a better design than exists initially when God has told us, I made it very good. You can't improve upon very good. So we have to learn to trust God to do things his way. And I would say most Christians don't even know they need to trust God when it comes to growing their own crops. I mean, they may pray and say, Lord, help me, but then they study science as to how it's grown. We need to recognize God has a design. He is the designer, and that we need to understand how that design is operating, and he in his mercy will show it to us, as he's showing us now what we need to do to restore the diseased land back to health again. That's a quote from Ellen White in Commentary 7a on Leviticus 25. That was our job. We were to restore the diseased land back to health again so it can be a praise and a glory to God. Let me see if I have that right handy here so I can read that statement. Men were to cooperate with God in restoring the diseased land to health, that it might be in a praise and a glory to God. Remember the first angel's message? Give glory to God. Well, this is one of the ways we're supposed to be doing it. And as the land that possessed would, if managed with skill and earnestness, produce its treasures, so their hearts, if controlled by God, would reflect his character. In the laws which God gave for the cultivation of the soil, he was giving the people opportunity to overcome their selfishness and become heavenly minded. How would he give them an opportunity to overcome their selfishness? Because every single thing in nature, if we study it carefully, we will find out every operation, every function of every living thing is all beneficial. It's all serving, either serving to maintain creation's design or redeeming and repairing creation's design. In the laws which God gave for the cultivation of the soil, he was given the people opportunity to overcome their selfishness and become heavenly minded. Canaan would be to them as Eden. How would you like to have your land as Eden? I've heard people come up and say this, because my farm, if I want to call it that, which we do for tax purposes, but it's my homestead. I've heard people come up and say, this is a piece of Eden here. They've seen how well developed it is and how beautiful it looks with all the orchards and berries and all kinds of stuff growing up there, and it's part of a city. But of course, this is an old colonial city that I live in, and these cities grew their own food. So I'm on the edge of the city, up in the mountains, that were the farmlands that supplied food to the cities before we had supermarkets. It would be as Eden if they obeyed the word of the Lord. It says, through them the Lord designed to teach all the nations of the world how to cultivate the soil so that it would yield healthy fruit free from disease. So we're going to be looking into that, free from disease. The earth is the Lord's vineyard, and it's to be treated according to his plan. Not only that, listen to what it says here. The next sentence says, those who cultivated the soil were to realize that they were doing God's service. They were as truly in their lot and place as were the men appointed to minister in the priesthood and the work connected with the tabernacle. This is a holy appointment that the 11 tribes were given. The priests and the Levites had their job. And so did the people. Their appointed job was to restore the diseased land to health so it can be a praise and a glory to God. So we have here the plants themselves and how God designed them to grow, and that we are to protect the microbiome that they carry, so that the rhizophagy operation, where microbes are engulfed by them, can feed them. Now, a little bit more about this engulfing process is that when these porous first 2 inches of a root swallow these microbes. I mean, they're porous. The microbes just, they actually, what the plant does is it exudes a diet that attracts specific microbes. They estimate 50 to 100,000 different species of microbes in the soil. And when the plant wants specific nutrients, it knows just what diet to make and exude in the soil. And then those microbes that feast upon it, and they have a very short lifespan, about 20 minutes. So within a very short time, within hours, there's millions and billions of them. And they can increase their populations by feeding a specific diet for all these specific 50 to 100,000 different microbes and increase their population, which increase the nutrition that those particular microbes are making. Quite a complex system, but really very interesting when you begin to learn it. So the plants themselves determine what the microbe population is going to be around them. They carry with them the microbes that they want, and when they want other ones at different times in their growth, they will exude into the soil nutrients that will feed those microbes, that will provide them that nutrition. It's very interesting, this whole system. There is no boron in the soil, a very important nutrient, by the way, for growing crops. There is no boron in the soil, in subsoil in New England. Yet there's boron in the soil. So you ask, how did it get there if it's not in there? Well, the microbes in the air took it out of the air. You see, the microbes, I said microbes in the air, I meant the microbes on the leaf of the plant that are in the air, or on the stem, or on the fruit. They're taking it out of the air. See, their job is to mine the soil, whereas other microbes their job is to mine the air, whereas other microbes mine the soil. So they take the boron out of the air, because all the ions float around in the air of these different minerals. They take them out of the air, and then they don't even give it to the plant. Well, actually, it goes through the plant, but the plant conducts it all the way down into the soil to feed the microbes in the soil. The microbes get fed first. The microbes get fed first. And then they convert it into forms that are the most beneficial food for the plant. So microbes get fed first. That's why I was just looking at some beds that were made, planting beds that were made at a church, and they brought in material and built the beds, and I could see there was way too much carbon in it. And carbon is just a chemical term for undigested organic matter. And it wasn't easy to digest organic matter. It was organic matter that needed a lot of greenery, a lot of nitrogen to digest it. And I knew that since the microbes get fed first, they were going to take all the nitrogen that was in that soil and utilize it to break down that woody material that the soil, this topsoil, is made of. They make some pretty cheap compost that they sell sometimes that's not finished, and it's got too much carbon in it, and the plants aren't going to grow too good in it. And so I saw that, and I said, well, you're going to have to put some nitrogen on it when your plants don't grow too good, because they're going to use it first. So the microbes will use the nitrogen first. If you have a poorly made compost that has too much wood chips in it, too much woody material, and it isn't digested sufficient yet, it's going to rob it. I've made that mistake in the past. Had too much woody material in the compost that I used, and my plants were yellowy and didn't grow very well because the nitrogen all went for the decomposition of the woody material first. So plants actually will sacrifice themselves to develop the soil. You know, just like Jesus came to sacrifice himself to develop us to be fit for eternal life again. So plants are feeding the microbes. They're born, we could say, with the microbe populations on them. They're created by the mother plant with the microbe population on them. That's going to assist them when they grow. So it's very important. The seed is a very important thing. And the best, now there's another aspects of seeds too, which makes homegrown seeds the best. Because the homegrown seed from your plants has developed itself in a climate and in a soil condition and with your farming practices. It has developed itself to adapt to them, to adapt to the climate, to adapt to the soil's condition, to adapt to your farming practices. So every season you want to save seed because it adapts itself to your environment. Environment creates adaptation. So that's your best seed. It will do the best. And not only that, every season you save it, it will do better the next year. So this is the way God designed things. There is adaptation. Some people call that evolution. They do evolve into better and better plants, but that's just the adaptation that God created to environments, environmental conditions. And he gave us a very good environment, and plants have adapted themselves to the way we've trashed it. Just like plants will adapt themselves to chemical fertilizer. They will stop feeding those microbes that they want to make fertilizer for them if there's an excess because somebody poured it on in water-soluble form, whether it's organic fertilizer or whether it's chemical fertilizer. They'll stop feeding the microbes that would make that fertilizer. And now you get a fertilizer that's imbalanced because only the microbes know exactly how much the plant wants, because it's the plants that's feeding them, and they feed them, and when they get enough, they stop feeding them, and the microbes just die off. They have a 20-minute lifespan. And so you don't have excesses when the plant itself, according to God's design, is feeding the microbes that give them their fertility. So we always try to fertilize ourselves, whether it's organically or chemically, and we do a very poor job of it because one of the conditions that we have to deal with, especially in agricultural land today, commercial agricultural land, is excesses of fertilizer. They built up and built up because we put on a whole bunch because we think, oh, the more we get, the more money we're going to make. And it does make more volume. And food is sold by volume, but it's poor and poorer quality because it's not balanced. And you have excesses. And when you have excesses of nitrogen, because the petrochemical industry likes to sell their nitrogen fertilizers, because that blows them up nice. That blows stuff up good, whether it's blowing up the grasses around manure in the field. If you take a look at a field where cattle or horses are there, you notice how tall the greenery is around the manure because of the excess nitrogen, but that's not very healthy. The animals won't eat it unless they're starving. So we have these microbes, and they're working to build the soil up, and we want to have them healthy and in good shape on the seed, and the best way to do that is to save your own seed. Now, when you want to grow some plants and a lot of plants, well, let's just talk about adaptation here and growing plants and adapting them to create for us new varieties. I mentioned about this afternoon about the Brassica oleracea, a succulent weed growing on the chalky cliffs of Europe, and how that these seeds, these plants were delicious. and pleasant to eat. They didn't have a lot of roughage in them. Cellulose material, we can't digest cellulose, even though the grazers can. And so we've selected them for, people grew this weed in their garden, and then they selected it for different parts of it. When they selected it for a flower, we now call that weed, Brassica oleracea, we call it broccoli and cauliflower. When they selected it for the stem, they called it kohlrabi. When they selected it for the leaves, they called it kale and collards. And when they selected it for the clumping of the leaves, they called it cabbage or Brussels sprouts. And so this is all just one plant, but it has many different traits in it. God put all these traits in there. He wanted us to have fun. The tall bearded iris, I work with a lady whose husband was an iris hybridizer. There are over 100,000 named varieties of tall bearded iris. There's so many they have to ask permission in the past for people to use that name again. That's how much variability is in these irises. They're all different colors, different shapes, different. And this is, God put this variability in things.
I need a garden.
And we also sometimes call plants different species. They have a species name for the Pakistani red carrot. They have a species name. It's called Queen Anne's lace here in the United States. But it's Brassica oleracea, excuse me, not Brassica oleracea, it's Daucus carotis. It's a carrot. And these reds and the whites of Europe were crossed a few hundred years back, and today we have the orange carrot, and everyone thinks a carrot is orange, but it's not naturally orange. They're red or whites. But they were crossed and selected and selected and selected, and they grew better and better and better. And we have these really nice carrots. You pull up a Queen Anne's lace around here, and it's just a white, spindly carrot root. And you do the same in the red wild ones, and you have a spindly type root. But you can select and select for better and better quality. Apples come from Kazakhstan. The mountains of Kazakhstan have native apples growing there. And as a matter of fact, one of the capital cities and one of the regions there is, in English, is interpreted Father Apple. And so, but these apples, when they started bringing the native ones, when they found out about it, once they were able to do genetic readouts and find out where the apple originally came from, they brought them to Cornell and they planted the seed, and they're what they call spitters. They'd have to spit them out. They tasted so horrible. So over the centuries, people have done their biting and spitting of apples until today, almost every variety we have, nobody really spits it out because they're all good tasting. They just have variations of good taste. So when we breed apples, we only breed them one with another to make a new variety amongst the ones that are no longer spitters. And we have a lot of plants that way. There were gourds. Gourds had toxicity in them. Matter of fact, in the Bible it says when Elisha was making that, put on the great pot there because the students of the prophets there were hungry, and it was a time of drought, and didn't have irrigation, proper irrigation, a time of drought. And so put on the great pot, and they did. And then someone ground up some gourds and threw it in there. And then someone tasted and said, there's death in the pot. That's because it was a toxic gourds. Well, today, all of our gourd-like things, squashes, pumpkins, there's no toxicity in it. We've separated that out. Lettuce only became an edible plant just at the turn of around 1900 or so, in that time there, because it had a contaminant in it called opium. And it was used for its opium-like qualities. Laudium, I think, is what they called it. And so we bred that out, but, it's pretty much out. There is some of that latex, a little in there, but it's not significant. And we bred out the rapeseed, canola. We think it's canola oil. That had a liver and heart toxin in it, but that was bred out. such that, you know, it's used all around the world as a seed oil. Although you don't want to use it anymore because it's almost genetically modified all around the world. And that has problems. So all these genetic modifications re-established bad traits back in it again. There's the wheat has that bad trait now of new proteins that never existed before, and rattlesnake poison is a protein, and so we have rattlesnake type poison, new proteins in this genetically modified wheat, which is why we have so much gluten intolerance. So we have these traits that never existed when God first created them. They were very good, Genesis 1:31, and then we changed the environment. We created these bad traits, then we bred the bad traits out of it, and then we bed the bad traits back into it again with genetic modification. So we're on a roller coaster, up and down, but to get off it, you study God's design and do things His way. So this is seeds and adaptation and the genetics. These are important things. The light, the water, the very soil itself, Genesis 2:5, and the plants themselves and the seeds and how we are to maintain the genes in them, creating the right environment so we always maintain the best quality. Right now, I have a garden full of different types of flint corn. Now, flint corn is a Native American corn. Corn was developed in the Americas by the natives here, and it's spread around the world. And but I'm planting a bunch of different ones because I'm trying to get some raccoon resistance. Evidently, they can be on the lazy side sometimes and not want to climb certain stalks that are strong or whatever, and they sort of like to climb and bend them over so that they can get at the ear. But if it doesn't bend over, they can get tired quick. And like the corn that I was growing last year was a Native American, was a Hopi Blue. I got it from the Navajo reservation. We have a Seventh-day Adventist mission there, and I got some through that and grew it, and it had been growing good, but they can climb that stalk, and yet last year the raccoons wiped out 95% of my flower corn. So I'm trying to get some hardy ones that make it hard for them to bend over. So I'm growing a bunch of different kinds, letting them all interbreed, and I'm going to be selecting out the hardy ones that they don't like to climb, and hopefully get some animal resistance. They all have disease resistance because they have selected over time because they did not have sprays or anything. So they just plain selected for the ones that weren't sick. You know, it's very interesting today in the breeding processes that we do at our university, they do not select for disease resistance. They purposely just breed and then keep on spraying. I wanted some disease-resistant grapes from the Cornell, which is our grape depository, Cornell University in New York, and I said, give me some that are black rot resistant, because that wipes out the grapes often here. But they didn't select for black rot resistance. They just spray anyways. And so they're not selecting for disease resistance. They want to continue the spray programs because there's a lot of money in it. And anyone that tries to get a grant for disease resistance, guess what? They don't get the grant to study it at our universities because they want to maintain the spray industry. So, but there was one time in 1963 when the oat crop in the United States and Canada failed, and that's a serious grain. It's used enormous amounts, and it failed, and so it failed, and they said, we got to do something about this, because they didn't have the sprays to spray for this pathogen, so they had to search for one with disease resistance. So they found one with disease resistance, and now they grow that kind of oats today, and that's why I use oats in my garden, because it, as a regenerator of the soil and as a fertilizer maker for my sweet potatoes and for other crops. I used the oats. So they found something that fed the microbes thoroughly, and that's why I had disease resistance, because those traits did not get shut off by fertilization, whether chemical or organic. And so you can grow oats and actually use it to rebuild soil and as a plant to make fertility in the soil for your crop. It'll make so much fertility in the soil that once you put another crop in after it, that the fertility that's in there in the form of microbe bodies will feed the next crop. And this is what disease resistance does. So this is what God wants us to do. He wants us to study every single thing for disease resistance. So when I plant peaches, I plant them by seed. And I'm looking for the ones that have brown rot resistance, because in the last 3 weeks of the maturing of a peach, brown rot will come in and wipe it out. And so I want the plant to have the ability. I just don't want to have run to some fungicides like Banzate or whatever and spray it on it to save my peach crop so I can eat my peaches coated with fungicide. I want a peach that has resistance to it. In other words, it's feeding the microbes that are going to give it the nutrition so that it won't get sick with brown rot. Same thing with the grapes and black rot. I want a grape variety that can feed the microbes that will give it resistance. So you don't need sprays. And that's what regenerative agriculture is. You're learning to use crops and crop seeds that are giving you nutrients so the plant is so healthy it doesn't get sick. And so that's sort of our goal. This is how we give glory to God. So I guess that gives a pretty good background here. I did want to talk about a little bit here of this brick chart here. This bricks new label for quality, and you can read this article here. It tells about how you can measure with a refractometer here. This is a refractometer. It measures the amount of nutrition in the sap. And that's important because, as it tells us in Leviticus 17:11, for the life of the flesh is in the blood. Well, the life of the plant is in the sap. So the sap is the one that tells us what the nutritional content is. Which bowl here is organic and
non-organic? First one, yeah, this one there, and then
this is organic?
the non-organic. This one is the organic one.
This is organic,
Yeah.
non-organic. Okay. These are the same type of apples, same type of tomatoes. Well, closest.
Yeah.
This is aroma, and this is another one. And then both of these are navel oranges.
Yeah.
Yeah. Okay. So we're gonna compare. We'll do navel orange to navel orange. Gary, could you get me take these 2 napkins here and get them wet, because I'm going to need to just moist enough so I can wipe my knife off it so I don't. Okay, so I'm going to the organics in front.
Yes.
Okay,
Right.
and so this is the non-organic orange, non-organic navel orange. Now, we're going to see what the sap tells us. We're going to squeeze some of the juice out, and we're going to take a look here and see what it says. It says 17 bricks. Now, this is the non-organic orange. Okay, so this is the organic orange. I'm going to have to, well, I'll wipe this off with this dry one, although we should better wipe it off with something moist, but it'll be sufficient. Now, this is the organic one. That one's 17 bricks. This one is, whoops, I have to keep it on here. It's hard to see in the light. This is the organic one. 12 bricks. The organic navel orange is way worse than the non-organic. Now, you may have expected to see organic be so much better, but you know, I have a chart at the end here. This page in the chart, it says how to increase, no, that's not it, how to increase nutrient density. Let's see where it is. Nope, it's not this one. There's, let's see, we'll find that paper. It's in here. Here it is. It says signs of food quality. And you can go to the supermarkets. As soon as I saw this organic one here, because of the porousness of it, as opposed to this one having a very thin skin, I knew immediately the organic was going to be worse. This one, by the way, Gary, is 12 bricks. The organic is 12 bricks. This is 17 bricks.
Wow.
That shows you how poor organics can be today. But in this chart here, signs of food quality for oranges, it says here, check one variety at a time, navels, then tangelos, then temples. Select the thinnest skin, smallest pores, thinnest skin, smallest pores. Smaller ones are not forced to grow big with nitrogen fertilizer. You know, like I said, nitrogen fertilizer, force it. You get more money, more weight. So, you know, whether it's organic or not, and it's better tasting and not as watered down in flavor as the bigger ones. So this tells you how to go to the supermarket and look for these characteristics and be able to determine whether you're getting some quality or not. So we'll just take a look at these apples. I would say, just looking at them here, you know, this, oh, well, we'll see. This one has a color. It had more sun. And when they're in the sun, this one didn't have as much color. Notice it's not in the sun. So it's probably a poorer quality just by looking. But we're going to take a look here and see what we have. This is the non-organic, and we'll see what its brick readings are. You've got that. We'll just wipe this off so that we have a clean, dry one here. And let's see. I don't have the light here. It's good. Maybe I can move this out of the way and do it in front of me, and I have better light so I can see what I'm doing. Hard to squeeze a drop of juice out. Okay, I think I've got a drop there. This is a non-organic, and 13 bricks. No, 15 bricks. 15 bricks. This is the non-organic, 15 bricks. 15 bricks is pretty good. We may find out. Let's see. Well, we'll just take it. We'll do it. We won't say anything until we have to say. Okay, so that's wiped off. Yeah, maybe we got enough of a drop to see what's going on there. And this is 12 bricks. So here again, the non-organic is much more nutritious than the organic. We'll take a look. Now, most people are used to trusting in organic as better. And let me tell you, I would still buy organic. When I need something and I can't grow it, I buy organic. And the reason I buy it is they didn't have these sprays on them. But they know how to organically blow them up and get big size so they can make a buck. Okay? So we're dealing with the hearts of men. We have to be the ones that glorify God by growing things in a way, especially if we're going to be a grower. And it's very difficult for the growers. I have a friend that's a grower, and he has a small farm, 1,400 acres, and he was saying, I put the minerals on it so that I have better quality produce. He says, but I can't afford it anymore. I'll go broke, he said. So he can't improve the quality of his crops because he'll go broke because he won't get the price for it. So anyways, that's now we're starting with the organic tomato here, and we'll see what we get with an organic tomato. Oh my word. Four. But that's normal. Very low, but that's normal. Very low is, and that's normal. This would probably be about a 4 too, if it's higher. Oops, that's a lot of juice. I don't think we need quite that much. That's a little too much. Four and a half. Again, look at it. The three non-organic were better quality than the organic. That's commercial agriculture. Once the big boys got into, the big corporations got into organic agriculture, plummeted. The brick readings just plummeted. They just said, you tell me, and the federal government got in on it for them. You tell me what I can fertilize with and what I can spray with. No longer, initially, the organic growers were improving the soil so that they were increasing God's microbe feeding of the plant. But now, once the big guys got into it, because they wanted to make a buck because it was higher money for organics, they just said, you tell me the fertilizer and you tell me the sprays that I can use and I'll use them. And they did nothing to improve the soil. Nothing. They just wanted to know how to get in on the money. So we can't trust organics for quality. I normally buy, like I said, the organic if I don't have a choice in the matter, but I also know that this chart here, if you learn it, signs of food quality, bear this in mind. If they show the signs of food quality and they're non-organic, that guy put on less spray, because he had some quality. You increase the quality, you need less pest protection, less fungus protection. So sometimes I will pick non-organic just because I could see the quality is there. So learn this chart here. This is in that this foldout that begins with the brick readings here. And the back side of this chart, or in the second sheet, these are the refractive index readings. Now, let's just say apples up here. This is fruits and these are vegetables. The apples, 6 is poor, average is 10, good is 14, and we got 15 on this apple here. We got a 12 and a 15. I think that's what the numbers were. So we got a little over good apple here because of the brick readings, okay? Notice that average, you get poor, average, then good, then excellent. That's how poor our crops are today that are produced. So we have the oranges here. These are oranges, 6, 10, 16, and 20. What was this orange here? I think this one, the organic one, was 12, and this guy was like, what, 17? So oranges, again, are 6, 10, 16. So a little over good. 16 is good, and 22 is excellent. So I bought this thing 30 years ago or so for $275. Because its use increased, I've had friends that have bought it for $19.95. So the price has plummeted and you can get it. So everyone should have one and go in the supermarket and look the fruit over. And if it looks good, take one, buy one. I mean, I just cut it right there and buy it. Yeah, cut it right there, see what the reading is, and if it's good, I buy a bunch of it. I buy a bunch of it. If it's junk, I just go buy that one. And you know, and so you can do this to get yourself a better quality food just by using this chart with a refractometer and using the guide here to help you determine what's a healthy plant. Now this here, this is called minimum brick readings, and at which and above no disease or insect or malady will infest it. Nothing will bother it. You won't have problems when you get them to these readings, but these are high readings. And you have to have some very quality soil. And this is what regenerative agriculture is doing. They're rebuilding the soil by putting other plants with the crops to get these kind of levels here. Okay, so this is what we're shooting for in our own gardens, is we want to be able to, and in our own homesteads, that includes the trees and the berries and everything else. This was a signs of food quality. Now, here's an article from New York Times I had, breeding nutrition out of foods, breeding it out. We can make selections for poor and poorer quality, and we do that when we select for cosmetic appeal. I think of Lofthouse, who did some work on, he wanted to grow cantaloupe high up in the mountains of Wyoming at 5,000 feet. He wanted to grow melons. And he had snow on the mountains in August. And so that's pretty cold environment. So he took 50 different varieties of melons, and he put them all out in the field and grew them, and almost everyone died. And only a few of them grew, and only a couple of them reproduced and produced seed, produced pollen, and actually produced seed. So he took those melons and he planted those seed in that field the next year. Well, they grew more now because they were all from something that could survive. And the ones that were sickly or didn't do this and that, he rejected me. Only took the very best. And then on the third year, he planted them all out again. And then that year, they were all pretty good because he had selected seed that was adapted to that environment and could grow good in that environment. And then he started selecting for taste. And when he got the taste, he only planted the ones with good taste, good brick readings, because these are sugar content readings. As the brick level goes up, the sugar content goes up. And that's taste. That's where it's at. And so he got the good tasting ones, and then he would sell them at the farmer's market. And people would come to buy his melons. They were every shape, every color under the sun, but it didn't matter. They all tasted good because he had selected for those qualities. So you can select and breed for uniform ripening, uniformity in size for packing, cosmetic appeal, adaptability to machine harvesting, and many of these characteristics, and just forget because it doesn't matter and it doesn't sell anything, nutritional content and taste. You can just, it's called dropping a trait. If you don't select for it, you're not going to get it. So, but that's reversible. I work for the Iris hybridizer, and she was telling me about hybrid tea roses, a beautiful rose with a long stem, and they're just elegant roses. This is what when you buy a dozen roses for your sweetheart, they're you know, that type of rose. And then the saying went around, don't go through life without smelling the roses. And everyone bent over and smelled. Where's the fragrance? There's none. Within 1 year, they had roses on the market, called the long stem, you know, whatever they were called, I forgot now. Those kind of roses with fragrance in them. They put the fragrance back in a snap, quick. So you can make your selections for quality. So that's why you save your own seed. So you can have this kind of quality. This is, but if you start breeding for commercial purposes, that's called breeding nutrition out of foods. Now, these are a couple interesting charts, and this is from these charts and the information that comes from an Adventist called Mittleiter, and he would go to the ministry stations that we had around the world and show them how to grow enormous quantities of food, 100% chemicals and 100% sprays, poisons, and but within 10 years, these things crashed. But he increased, and so he taught how to recognize nutrient deficiencies, and he has pictures in his book. This is The Garden Doctor, and there's 3 books here with this here, and it tells how to recognize nutrient deficiencies in your crops. And so, for instance, a simple one, beans and peas. If you have missing beans and peas in your pod, you don't have enough potassium. So I noticed missing beans and peas in the pods, and so I put on ashes. When I plant my beans or my peas, I just save my ashes from my wood-burning stove because I know it's high in potassium, and I just put it on, and all my pods are full. If I want nice size onions need a lot of potash to fill out, and I just put ashes on them, and they fill out nicely and give me nice size. And so this tells you how to recognize. I just did 2 charts. One is boron deficiency, and the other one is potassium deficiency, because these are the most common ones in Connecticut where I grow. So I just threw them in here. So we can recognize by the crop. So this is the list of crops and how you can recognize. And he gives, and every one of these mineral deficiencies that show up in crops, he gives a list of the crops and what they look like, pictures of what they look like. So you can learn to be your own doctor and recognize, okay, that's missing here. I'm going to have to add this. And so you do that. Now, here's another interesting chart. And that's in that chart. Let me get this out of the way here. And this one here is tells you, for those who can recognize diseases and recognize insects, if you have these insects or you have these diseases on your crop, in this case here, it's just tomatoes. This is tomatoes and tomatoes, eggplant here. And if you have these diseases on your tomatoes with these disease conditions, that tells you you have these nutrients missing. So that correlates that disease is directly related to nutritional deficiencies. And this is what this chart indicates. And also insects. And by the way, the most common nutrient missing in almost every problem here is calcium and phosphate. Calcium is needed in the greatest amounts and phosphate in the second most greatest amounts. And so, they're just deficient in most of the soils that are being used. And what we need to recognize is they're really not deficient. They're there. In almost all these soils, they're there. They're just not able to be used by the plant. And the reason the plant can't use them is because it's not feeding the microbes that will take them and feed them to the plant. We're depending upon a water-soluble fertilization system, whether it's organic or non-organic. The water-soluble fertilization, that's like taking bread and shoving it down a duck's gullet, and because it's got a long neck, they can push the bread down in their stomach, so you get a nice, fat, greasy duck for the people that eat ducks on that market that sells ducks in New York City. You can force stuff into things, but that's not the way. In God's design, you have the microbes do it. So you can force feed crops to blow up and give you obesity, just like we give that kind of food to kids today, and now we have an obese population of children. We can use that system, but we don't want to use that system. That's not a good system. And then I have one more paper here. The last one here that I'm going to cover this evening is how to increase nutrient density besides improving the soil. Besides improving the soil. And the sap, remember in Leviticus 17:11, the life of the flesh is in the blood. And so remember, it's the sap, as we just saw there, that gives us the quality. One of them is spacing. You have to have enough spacing between your plants. And it varies according to where you're growing. If you have a richer soil, you can space closer and get good quality crop. In a poorer soil, you got to space your plants farther apart because there's not enough nutrition there. So you learn to space your plants according to how much nutrition is available in the soil. And remember, usually the limiting factor, almost always the limiting factor is microbial housing, which we call organic matter or the humus. That's almost always the limiting factor. And so as you increase the organic matter content, that's why they started out calling it organic gardening. And organic gardening should have morphed into the organic market, improving the soil. But that's the one thing the big boys didn't do, is improve the soil. They stopped. They didn't want to bother with improving the soil and increasing the organic matter content. They just wanted the revenue from using the sprays and the fertilizer. So you increase the organic matter and you can start growing them closer and closer together because now you have more housing, more microbes, more of God's design of fertilization. You can thin fruit on a tree. You get peaches. I remember I used to do it as a kid, and it's real fuzzy work, itchy and hairy, but you got to thin peaches all day and you space them a certain distance. And we were told to space them about 4 or 5 inches, but there was one guy, he would say 6 to 8 inches apart, and he'd hop on the people if they didn't pull off. And sometimes you'll have a branch 20 inches long and you rip off 16 peaches and throw them on the ground. And you just leave 1, 2, 3, 4. That's it. Because they'll produce that many. So you thin them out, and that way you get bigger flesh on the seed. Other than that, they'll leave all those on there and just develop the seed inside, and you have almost no flesh for the peak. So the same thing with apples, the same thing with pears. You get higher quality by thinning them down. So you can determine what brick level you want by how far apart you thin it. And this guy was selling to the high price crowd who was, say, demanding 6 to 8 inches apart instead of 4 or 5. So you can prune during the wintertime. You take off some of the branches and you let more light in, and so you have better sunlight in there. You get the leaves are able to produce more chlorophyll, and the branches buff up and get stronger now because there's more potassium to go around, and potassium is the stem strengthener. That's why you get lodging in wheat that's not genetically modified that grows 4 or 5 feet because there's not enough potassium in the stem. So when you remove some of the stems in pruning a tree during the wintertime, you increase not only the light penetration and decrease the amount of branches that produce fruit, but you strengthen them, the branches, so they can bear heavier loads. And you can, by variety selection, you can select for wrong reasons, or you can select for good reasons. And I always select for sugar content, good taste. It's got to taste good to me. And then I remember putting in beets, because beets often taste like dirt. And the most common beet varieties grown, taste like dirt. But then I grew a white beet, and I grew a chayoga, a peppermint striped beet, rings of red, white, red, white, red, white. And they had the higher sugar content. The white one was the highest. The chayoga was next, and the rest of them taste like dirt, the common one. So you can select for the variety. for the sugar content that you want just by, tasting the varieties. So varieties have already developed. You just want to select the ones that have the best flavor, the best quality in it. And then rootstock. Now, rootstock is very interesting because just about no trees are grown on their own rootstock anymore. I was just reading a report on the rootstock for citrus, and I think it was grapefruit. And initially in the citrus industry, they used to grow initially sweet oranges on sweet orange rootstock. They'll find a sweet orange that has rootstock that's more vigorous, and they grow it. But then the sweet orange rootstock did not produce as much orange because the soil got poorer and poorer. And as the soil gets poorer, they produce less. So they switched over to sour orange. Well, sour orange doesn't require much nutrition because they're sour anyways. Your nutrition is what gives you the sweetness, the flavor. So they switched over to sour orange. And then they weren't getting much because they wore the soil out even more. So they switched over to lemon rootstock. Now I'm hearing recently they're switching over to varieties of modified lemon rootstock. The soil gets worse and worse and worse. And instead of repairing it, they just switch to rootstock that will grow on it and give you something. But the nutrient content is dropping and dropping in the final product. So rootstock makes a difference. Dwarfing rootstock on apples is nothing more than choosing sick apple trees and grafting onto sick apple trees, because sick trees will try to produce a crop quickly. And when you're investing in an orchard and you have to wait for a standard apple to produce fruit to start being able to pay back for the money you borrowed, and it's going to take 5 years, when you can grow it on a sick rootstock that will start producing fruit within 2 years, and you get your money back on your investment, everyone's going to sick rootstock. But the quality decreases. You can get the brick levels, remember, by thinning. But the quality, if you're using sick rootstock, you're going to be missing some nutrition. Even though you can boost up the brick levels, and that would supposedly bring up most of the nutrition. I suspect if you're using sick rootstock, you're missing something. Just like the rootstock for seedless watermelon or seedless grapes. What you have there is you have a type of root that will not allow manganese up into the top. And so now you have a manganese deficiency, so you have no seed. Some people think that's an improvement, but we need manganese in our diet. And then we have seed quality is recognizable by a heavier seed. If you are sold an ounce of this type of seed and they tell you that in it there's 100 of them, and then you buy another ounce and they tell you there's 200 seed, buy the one with 100 seed, because they're heavier, because they have more density, they have more nutrition. It's a better quality seed. And another thing to look for is adaptability to your climate. You may be having trouble growing something only because it's not adapted to your climate. It's more adapted to a different climate, a different soil condition. So for instance, Wisconsin 55, very good tomato in Wisconsin. Growing in Connecticut, not very good. I phased it out. I like the best tasting apple to me that grows in southern New England is the McCowan. You take a McCowan and you grow it in Wisconsin, it's not worth much of anything. You take a Jonathan in Connecticut, I would not choose to eat a Jonathan. I'd eat other varieties instead. But you grow that Jonathan in Iowa, best tasting apple in Iowa. You take another one that grows, I forget, it grows in Northern California and it grows in Nova Scotia. Excellent quality apple. I forget the name of it, but If you're from Northern California, you would know what it is if you knew your apples. And from Nova Scotia, because they would say, oh, that's the best. But you grow it in other places, it's not that good tasting. So adaptability to climate is going to determine nutrient content. And also the last one is the design of the planting bed. I learned this from a missionary to India and Nepal, and they had learned this. It was called the Ayurveda, and I guess that word Ayurveda, I'm probably saying it wrong. Are you familiar with that term?
Ayurveda,
Yeah, Ayurveda, am I saying it right? I don't know how to say it. I just read it. Anyways, that is an Ayurveda way of growing. That word Ayurveda means life, just like bio is Greek for life, or vitae is Roman for, for life. And so that they can increase the life and the vitality of the plant by planting a design. And this is the bed design. And she did it, the missionary, she did it, and she said it worked. She took, you take red, these are anthocyanins, red, blue, or purple. You plant one plant of red, blue, or purple, and the other plant of either green, yellow. Those are the phases, the green, yellow phase, red, blue, purple. And you plant every other. So you plant red cabbage, green cabbage, red cabbage, green cabbage, red cabbage, green, and you'll get more vitality in it. You'll have less pest problems. You'll have less problems with the crop. You can take red cabbage. Well, I do, like I have in the truck there, red kale, green lettuce. I was going to plant it, in some of the beds. I thought there'd be a lot of beds we can put them in. And so you plant that down there so you have color. And then the other is aroma. I bought a whole bunch of garlic that I had left over to just put in there. It could be any of the allium family, which is garlic, onions, shallots, on and on, chives, the whole works. Or it could be, your basil plants, your thyme, your rosemary, or something, plant these there. And so you have those, they will increase the nutritional content and the vitality. When you increase nutritional content, you increase the vitality of that plant there. And then another thing they put in it is cleft-leaved plants. Now, cleft leaf is basically one family, and it's the umbelliferae family. And this would show you what the umbelliferae family is here. And these are your things like a carrot leaf. That's in the umbelliferae. It has a flowering that is an umbel. It looks like an umbrella with the ribs of an umbrella and the flower on the top. Your carrot, your dill, your celery when it goes to seed, your parsley when it goes to seed, and they all have the cleft leaves. You plant that in there. They even use that as borders. And then the other thing they plant in there is hairy leaves. And hairy leaves, as opposed to smooth leaf, basil is smooth, cabbage is smooth, but you look at a radish leaf or a turnip leaf, it has hairs. You look at a cucumber leaf or some of the other leaves, your pumpkin or squash leaf, they have that hairiness to it. You interplant them with something with a smooth leaf. And when you do this, you get an increase in the vitality, increase in the life forces of these plants. So planting design, Genesis 2:15, we were to keep the design he gave us. God showed us how to plant. We are to serve the garden, and a garden is a planting. A garden is not just an ecosystem out there growing wild on its own. Because remember, God took Adam eastward into an ecosystem that was beautiful called Eden, and there he planted a garden, and that's a planting design for him. And he said, I want you to keep it this way. So he gave us a design that we're to keep. And I suspect this design, since this has been recognized by the natives in that part of the world, in India, as beneficial and increasing the life forces, that this garden that he gave them had planting design that would enhance vitality in life. Okay, well, that concludes what I have as
Q&A.
so. What do we want to do? Question and answer from
Yes.
here on out?
Yes, so we can do some Q&A, and I know that we had some questions in the chat prior. Someone was talking when you were showing the brick system. I guess you kind of answered the question already when while they were asking it, because they were wondering if shouldn't they get organic, even though it's not as nutritious because of the free from chemicals and toxins
That's a
and
choice you make.
yeah. So then what we wanted to illustrate with this there is not to bash on organic, but to show you that the best ideal is to grow your own food, because then you can get the both worlds. You can get the organic and you can worry about the nutrition density as well.
The Organic Gardening magazine that started this organic gardening in the United States by the Rodale, that was doing it the right way. That was increasing the organic matter of the soil. Commercial agriculture today, growing organically, is not really organic.
Yeah.
Not growing. It's just a name that they can now get more money on.
Yeah, definitely become commercialized nowadays, and it's much more expensive, and it's
Much
just
more expensive, and
very
you can
commercialized.
see it can
Yeah.
be all poorer.
Yeah.
Okay.
So it's free from toxins, but still might not be as high nutrition, even when with the non-organic. So I see someone here with a question. I am going to ask you, Veronica Ann Williams, you can go ahead and unmute yourself, and then you can ask your question.
Good evening and happy Sabbath. Thank you so much, Brother Travers, for documenting the knowledge you have learned. It is invaluable, and I appreciate your generosity in sharing it. And my question is, let me see how I can say this. And I apologize if you covered this maybe yesterday or something, but my question is, and I'm trying to say it as succinctly as possible. I have been trying to learn how to compost. And in trying to learn how to compost, I understand that I did something wrong in holding my compost until I can put it in the bin. So I have a bin in Maryland, but when I'm in New Jersey, which I am a lot, I would keep my raw scraps from fresh produce in a Ziploc or in a container. And because of the heat or time, it because it's not open, it's bubbling or whatever, or has an odor. And I was told that I need to throw it away, that I cannot use it at all, that even if I dump it in my compost or even create because I was thinking of creating a compost bin in New Jersey as well. Um, uh, so I was like, well, I'll just keep this in New Jersey. We got the compost bin. I just don't want to start it wrong. I brought my leaves from New Jersey, and I have these containers of things I haven't yet thrown away, even though I was told to throw it away. Wanted your opinion. Is it, and I have some fresher, quote unquote, newer produce that hasn't been in the bag as long, or the container it is in has some holes, like for example, leftover blackberries. Some of the blackberries molded. So I said, up, put it there. I'm gonna throw it in the compost bin. Wanted to know, should do you agree I should throw it away and just start fresh, or the time that it's been in the plastic, it
Throwing away or start fresh, but you'll have to give me the question because I can't hear well.
yeah. Should I throw away what I have? I hope you can hear me. I have go ahead. Go ahead.
Yeah, so you had some compost and you said that it was going bad. You kept it in the bin for too long.
No, not compost. No, not compost.
The produce,
raw scraps. Raw scraps. Yeah.
So you were collecting some scraps in a plastic bin, but then someone said that you left it too long because it began to sour, it began to bubble and stuff like that. And they said to throw it away, it's not good anymore to use in the compost.
To put in my compost bin, and I'm asking, is that true?
When she when she adds other materials to it and the air starts to get in it, it will switch over from
That's
anaerobic
exactly
to
what I
anaerobic
thought.
underneath them.
That's
Yeah.
exactly what I thought. I said, that doesn't make any sense. That's
Yeah.
all it's going to do in there. All I got to do is add some more brown or
Right.
whatever it is to
Yeah.
balance it.
So he said, you have the answer. You got it. So
So it's not true then. It's not because there's some flies coming around it. And I was like, that's okay. On a good day, I'll just gear myself up, move everything away. I'll put the leaves in this is a brand new the compost bin in Maryland is closed. It's whatever superpower plastic. This one is a silver stainless steel one. Looks like a silver trash can to me, but it has holes in it. But it's called a compost bin. And I have some leaves. I'm going to throw.
okay. Looks like we lost you here for a little bit. 1, 2. Okay. So it seems like we lost you. Okay, I think you're back now.
Oh, okay.
Mhm.
I was saying I'm just going to add some fresh leaves into this brand new stainless steel garbage can looking compost container that we bought. It has holes in it. I don't know how it has these holes in it about the size of a dime all over it in different places, but it looks like a silver trash can with a lid. Doesn't have anything to turn it. And you don't turn this one. I guess I got to get a long stick and turn it. I'm not sure. And I have some leaves. I'm going to put the oldest, yucky, wet, bubbly, old produce in there. And I have some newer produce that's fresh. Like I have some fresh bananas. Not bananas, banana skin. I'm going to put in there and others. And I figure over a while, it'll convert itself, right? And I'll know because it won't have a smell, right?
So definitely. So he said definitely it's I mean I wonder if people have smelled compost before. You know, I mean it's not always a pleasant smell, you know. So
Right. And I
yeah,
thought that
and
and the bugs didn't bother me because I figured the bugs mean that it's a good thing. If bugs are
yeah,
there, that's a good thing, I
Well,
thought.
you really don't want that stinky smell
yeah,
to the
not yet,
compost,
not yet.
but she knows what to do. You
Yeah,
add more of the
yeah,
aerating stuff so the stink will go away
yeah,
and
yeah.
it'll start composting the proper way.
Yeah, yeah,
Which
yeah.
Okay. And I don't necessarily have to add eggshells, or do I don't I'm plant-based. Do I have to add eggshells to my compost, or can I just do leaves, fruits, vegetables, or do I have to have eggshells?
She's actually if she needs to add some eggshells to a compost, since she's plant-based, she doesn't really have those eggshells, or can she just do the fruits, vegetables, leaves, and so
she can add eggshells, she can add oyster shells, she can add, when you add lime to a compost pile, what you're using is shells,
yeah,
antediluvian shells.
yeah.
And it's good to add lime to a compost pile.
And would
Okay.
can charcoal take the place of some of that, like adding some of the lime in?
Well, you can, charcoal is like the finished product of compost.
Mm.
Charcoal is a
Okay.
product.
Yeah, yeah,
Charcoal does not compost it's a finished product.
yeah.
And what you're doing when you're composting is you have organic matter and you're trying to have it break down into a finished product called humus.
Yeah.
Okay.
But humus are equal in their
Okay.
in their use by the microbes.
Thank
Yeah.
you very much. I appreciate it. Do I rinse the eggs or just put the egg when I get them from somebody that eats meat? Do I just take the eggs and as they crack them, just put them in, or do I need to rinse the eggshells off?
So she's
You know,
actually if she needs to rinse the eggs off when she gets it from someone else, or is she just put them in just like that?
Throw 'em in.
She just
Thank
put
you.
them in, yeah.
Thank you. Thank you.
So someone asked a question prior, and by the way, for those who are signing up, we're going to share a link very soon. Those who are signing up, and who's going to be here on our property tomorrow for the practicality of this workshop. You know, it will be from 10 to 5. We have quite a bit of hours. We'll be covering a lot of practical information. We'll be talking about more about compost and stuff like that, and also you can talk. We're going to discuss more about the ratios or what to add in and stuff like that. So that's going to be covered in our class tomorrow as well. So someone asked before, whilst you were speaking, someone asked, where can I get information about what to keep squirrels and other critters away?
Yeah, I'd like to know some of the ways to keep
Do you
them
need to get
away
a
too.
gun? I'm just kidding.
No, yeah, no, I've used a gun. So they now have solar powered and it's my sister solar powered noises like a hawk or different predators that dissuade the animals and make them go away. My sister, and some of them are fairly good one. Now, my sister likes the owl because the solar power even works on cloudy days. But
Yeah.
and it makes a sound that I can't hear. Some of those sounds are annoying when you walk near it and it triggers it. It's like, oh man. But yeah, they have animal deterrent sound makers,
Okay.
solar powered even. So
Yes, and that's something that we want to experiment with as well.
yeah,
Different sounds, having the scarecrows and having all different types of
yeah.
stuff to keep animals away. But yeah, so someone else asks, Sister Dawson, I tried to get my plants started early on on this time of year, this year, and the weather has been horrible and my plants are starving, yellow, etc. What can I do to keep them healthy until I'm able to plant them? The weather has been cold, wet, windy, and at times very warm.
If they're yellowing because they want to grow and your pots are too small, you can add some chemical nitrogen, but I stuck mine in the ground and let them be on the yellowy side in the ground because it's cold and it's wet, you know. But I know this week when it gets up near 80, they're going to take off.
Yeah,
They're going to
yeah.
jump.
This,
But when you leave them in the pots, they start stunting,
yeah,
which
standard
is what
growth,
I
yeah.
don't like to do. I don't like leaving. I put them out when I time to put them out. I put them out. If
Yeah.
I plant them so that they're ready to put out after there's no chance of frost, and regardless of the weather, I put them out
Yeah.
because I want them to not be stunted. If they don't go anywhere because it's too cold, too wet, whatever, okay, so what? They'll take off when the heat comes.
Yeah, and you know, the weather has been very strange, even by us here. For most people this year,
Yeah.
it's been can't make up his mind if it wants to be warm. It's been
Yeah.
raining nonstop. It's very strange weather this year,
Yeah.
but
Yeah.
we have to do what we have to do,
Yeah.
and we do our part, and I guess God can bless the
Yeah.
rest for us.
Yeah.
So someone asked another question, Sister Bernadine, and she said, "Can seaweed be added to the compost?"
Can what?
Seaweed be added to the
Oh,
compost.
it should be.
Yeah.
Everybody should be putting seaweed in the compost. That is what gives you quality.
Yeah.
Really quality soil is the seaweed.
And you spoke about the algae, you know, having that and
Yeah,
having
those
all
are
the
all algae.
yeah, yeah, yeah,
The kelp and the dulse
yeah,
and we going to go down to the coast here because we're near the coast,
yeah,
just an hour away, and we get it by the truckload.
yeah,
And
yeah.
that's very beneficial, very beneficial.
Yeah, definitely. And also, you talked about how most of our soil, a lot of the stuff has been washed away into the ocean.
That's why it's so
And
beneficial.
and the ocean is very nutrient dense, and the
Yes.
seaweeds absorb some of the
Yeah.
nutrients from there. So
Yeah.
yeah, so that's great to add to the soil as well. And what about something like, let's say, people do like the alfalfa meal just to help because
That's a lot of nitrogen. That's
Okay.
that's a Cherie asked about what to do when they're yellowing because they have nowhere to expand to, nowhere to grow their roots to. They can use alfalfa meal,
Okay.
and and that'll help. But they can also use weed tea. You just get some weeds and crush them up and put them in water, and that's not as expensive.
Yeah.
It's called free instead of expensive alfalfa.
Yeah. And I guess that's another method of composting, you know, having them break down a little quicker, water soluble, and
Yeah,
then you
It's
can
a-
even
it's a
water
food-
your crops with those too, right?
This is all rescue chemistry,
Yeah.
natural rescue chemistry, but we want to develop healthy soils. But in the meantime, we've got sick soil, so we have to learn medicine.
Yes, definitely.
Rescues.
Become a medical missionary for the soil.
Right.
Any other questions? You can feel free to unmute yourself. Also, if you don't want to talk on the microphone, we can post your question in the chat and I can read it out for him so he can answer some of the questions that you may have right now. And if not, if you have no more questions, we'll end at this time. But if you do, we want to just entertain a few more questions just to make sure that we answer everyone's questions. Okay, so I see one is posted here. So thoughts on growing in bags. What is done differently than in the true ground, please? Can you do regenerative gardening in bags, or is it impossible?
So wanted to know about growing in bags?
Yeah, bags. I guess maybe bags, even in pots too. Maybe that's what you mean,
Yeah.
like containers and
Grow
stuff.
bags are cheaper than,
Yeah.
yeah, but yeah, you can grow in pots, but you're only going to get as much in those pots as the roots can expand. There's a limit because once they start hitting the edge of the pot, they'll start going round and round. They'll say, okay, that's it, and then won't grow any bigger.
Yeah.
And also, too, it depends on what you put in that pot. Since you're the one providing the soil, you're only going to get the quality that you have of the quality of the soil. So, yeah, you can grow in them. You don't
Yeah.
have any other way? Yeah.
Yeah.
Sure.
And also we tell people like start where you are. If you're in an urban
Right.
environment, you don't have nowhere to grow, like
Yeah.
don't make that stop you from growing, even though it may not be the most nutritious, it may not be like the
Right,
soil, you don't have all organisms in the soil that you get,
to
you know.
practice
Yeah,
serving the plant, and that's the purpose
Yes, yes.
of this of agriculture that God designed for, so we would learn to be servants,
Yeah.
good servants.
Definitely. And
5-gallon buckets are an awesome thing.
Yeah.
5-gallon
yeah, the
buckets.
5 gallon buckets, someone else mentioned as well,
Yeah.
that you can use. If you're in urban environment, just
Just
get
if you
as
do it in
much as you
5-gallon
can.
buckets, make sure you have holes for
Yeah,
drainage.
some holes for drainage, and have a platter or something underneath to collect water when you water to your plants. So if you overwater, it doesn't all go on your ground. But someone asked about the gadget that was used. So that's the refractometer.
Yeah.
And then you can see the sugar content, which is the indication of the nutrient density in there.
Yeah.
So that you can get that on Amazon. Like he was saying, some people get it for $19. Actually, I was just about to buy one online, and I got it for 20 something dollars. I was going to order it from. Back in the day, as you said before, when I looked at those things,
Yeah.
like 10 years ago, it was pretty expensive. It wasn't not as commercial as it is today. So someone is asking for the recordings. Yes, we will have some recordings that will be posted later on. Someone said, I bought a solar thing for moles. Will it work?
You tell me.
So you I guess
Tell you
experiment
so we can know.
experiment with it and see how
I
it
don't
goes.
have moles as a problem, so
Yeah. So
right.
around here we have the deers is the biggest one, and then we have the deers that will take it from the top, the rabbits that will take it from the bottom, and so you have to experiment in how to keep those things away.
Walk over and
Yeah.
see the woodchuck too. The woodchuck.
Yeah,
woodchucks are they're big eaters.
Yeah, so the woodchuck as well. So every environment is different. Everyone have different animals in the where they live. And you just have to experiment in how to keep those things away.
Yeah, right.
So there was a family that we met in bordering New York and Pennsylvania. And what they did, they took like the cow manure and they used to they put in some water, the cow manure water, and spread it around the border of their garden, like maybe every week to try to keep some of the animals away. But sometimes animals get adjusted to certain things, and what you do stop working, it wears off. So you have to keep changing and switching things you do. So someone asks, what is the cause of cutworms and how to avoid them?
Cutworms just means you've got problems in the soil. What they are, I don't know in particular, but when you have plants that they like to cut off, take 2 toothpicks and put one on each side of the stem. Because in order for the cutworm to cut off that little plant, they have to wrap themselves around it. And when they have the toothpicks, they don't. And that, if you want to do that, toothpick one on each side of the stem.
All right, so
when
there
you
we
put
go.
the little plant in.
So toothpicks, and that will help to prevent the cutworms whilst you continue to feed the microorganisms in your soil, just to improve the health there. And she said, thanks, it happens to her beets.
What's that?
She said, thank you, but it happens to her beets, the beets that she grows.
Thank you, but it happens to
Her beets, the red, those beets that you were talking about earlier. Yeah.
The cutworm eats her beets.
Oh, wow. That's interesting. Usually it's just a stem they go for.
Yeah.
But okay, if they, well, if they only take one leaf at a time and you've got more leaves, not that big a problem.
Okay. Are there any more questions before we end off this evening? And what we wanted to do here is just to share about our gardening workshop. This is a free class that we wanted to open up to everyone, to the public. Someone asked in the chat, how can they get access to the training? They don't live close by. And I kind of figured that out, that a lot of you guys are probably in other states or other countries. But for those who are local, you can come by, whether you drive 2-3 hours away. We have also, if you get like lunch meal tickets, we will cook lunch and provide it here at the center. I posted a link for more information about the workshop that we'll have tomorrow. But we are not live streaming it. It's going to be in the forest. No access to internet out there. And also it's going to be a very practical class as well, tomorrow. So the class is going to be tomorrow, and it's going to be very practical, as I said before. So we're showing you how to prepare beds. You actually be digging the soil and turning over the soil. And also we'll be troubleshooting our soil here because it's not perfect, where we've been growing. So then we'll be troubleshooting our soil as well, and you'll be helping out with that. And demonstrations will be shown how to transplant some of the foods. And also you guys will be starting some seedlings as well, that you can take home with you as you go home. So I have the link here in the chat. You can learn more about our workshop. We love to get as many people as we can. Sign up online as much as possible. I know maybe some people might even show up without signing up online. So if you sign up online, then we know how many people are coming, and we know how to prepare lunch and so forth for everyone that will be coming to our workshop tomorrow. So the workshop, as I said before, begins tomorrow at 10. And then we have lunch in between there at around 2 o'clock. And then we convene again and we end off at around 5 o'clock tomorrow. So we're covering a lot of stuff like the composting. We'll be covering how to prepare beds, how to do composting, how to add, some organisms, how to awaken some of the organisms in your soil. And also we'll be talking about like different wild edibles that can be seen around the place, that we can identify. And we have Brother Jerry Travers, who's been planting for many years. And also, myself, we run this lifestyle center, so we can probably even talk about some of the medicinal benefits of some of those wild herbs and stuff that we have out there. So it's going to be a lot of information that will be shared tomorrow. So we're praying that many of you guys will show up and also sign up for the workshop. And you can sign up right there. And also, in addition to the workshop, we will be providing a lot of guides as well. We have prepared, some planting guides, some chats, also some zone chats as well, show you what can grow in the zones that we live in, especially here in the north. So then all that will be provided to you guys as free resources, and some of the resources that Brother Jerry has as well. We'll be providing all those digital resources for everyone that signs up for this training. So you'll have a digital copy of all the resources and all the planting and the chats and the guides that will be provided to you as well. So we pray that all of you guys have a blessed evening. If there are no more questions, we'll end off here this evening. This will be it for this evening. I pray that you have been blessed. This, as many people have been asking, this has been recorded and this will be uploaded for free for everyone to be able to watch it online. But the tomorrow class, no recordings for those. And also it's going to be very practical and hands-on. Hopefully next year we want to have another one as well, and we get more people. So that will be a blessing as well. So if you want, you can probably end off in prayer, and if you want to give any outro, then
Okay. Lord, you are the designer, and we have to recognize this. And you told us the design was very good. So therefore, Lord, we have to learn how it operates. And when you tell us that if we do things your way, this will train us, Lord, to have your character of a servant. So, Lord, there are more than just the benefit of nutritional food for us. Your glory is brought to you when we do this, and not only in the restoration of our ecosystems around us, Lord, but in the restoration of our very character. So, Lord, we thank you for all your goodness and all your redemption. In Jesus' name we pray. Amen.